Hello everyone. Today we're going to be looking at the fundamentals of the chain rule, and this is a rule we can use in order to find the derivative, and I'll just go through what that means now, and then we'll have a couple of examples in this video just so you can see whether you fully understand it. So this is the fundamentals of the chain rule, and if we were to write our f of x in a form where we could use the chain rule, we would have we may have a coefficient at the front, we may not, but we generally have some term that's in brackets, and then it's raised to the power of n, any given sort of power. It could be any real integer as such, or even a fraction, or anything. But the main thing we want to do here is, if we want to find the derivative of this, the f prime of x, then what we need to do is we need to follow this form from this formula here. So, as I said, the e may or may not be in there, depending on what problem you're solving. But what we do is we have the f prime of x equals the dy over dx. So of course, we're just talking about the derivative here, which is the slope at any given point on a function. It's a function that represents the slope of another function, if I were to put that nice and simple there. So what we do when we're using the chain rule is we take down our coefficient first, our exponent first. I got a bit ahead of myself there, and we multiply it by the coefficient e. So we'd have n to the e, nice and easy. You can pretty well see what I've done there. And then we just write the exact same g of x as is. We don't even need to touch it. That's the great part about it. And then we just subtract 1 from our exponent, and that's what this whole thing will be raised to, before having the g prime of x in there. So the derivative of just what's in the brackets here. Our g prime of x is just what's in the brackets. And our actual derivative of just what's in the brackets will go on the very end. So, you're probably sitting there thinking, oh god, that's quite a long, complex chain there. If you pardon the pun, obviously, because there's a chain rule. But I'll break it down, we'll do a few problems, and hopefully you can feel really confident with this concept in differential calculus, because it can definitely help you out. It can save you a lot of time if you have to go through the first principles and use this kind of equation. So let's start off nice and easy, where we don't have an e coefficient at the front, where we just have 1 take 3x to the power of 4. And the 1 take 3x is in brackets. Okay. And what we want to do is we want to find the dy over dx's term, the derivative. So, find the derivative. And that, we can just say, is our f of x, and the g of x in this form here is just what's in the bracket. Okay, so now that we're all set up, the very first thing to do is take that exponent, as you can see here, and multiply it by the coefficient. So let's do that. Let's imagine we have a coefficient of 1 there, just for the purpose of this. In this case we don't, so it's really just moving 4 there, because it's going to be 4 times 1. So 4. Then, our next step is to write the g of x term as it is. So I'm just going to copy it down. It's really easy. 1 take 3x. Very simple. Now, what we do is we are going to subtract 1 from our original exponent. Our original exponent was 4, so now it's going to be 3 when we take 1 away. And then what we do is we find the derivative of our last term. So let's do it, and we find it just for what's in the brackets. Okay, what's the derivative of 1? Nothing. There is no derivative of 1. There's no derivatives for a constant, because if we use the power rule, we can see that it will always be 0, oh, just 1, really, or 0, sorry. So, what if we were to take this, say, 1 to the 1 there, and we were to bring that down and make it 1 times 1, then we'd subtract, or 1 from the numerator, and it's pointless, really, so we just forget about the derivatives of constants, and we move on to our negative 3x there. And, what happens when we do? Well, negative 3x. What would the derivative of that be? Well, we just pretend it's x to the 1. We bring our 1 down to our negative 3, and 1 times by negative 3 is negative 3. And now that's x to the 0, it's just counted as 1, so we don't even need to write it in there. And we're all done. Ta-da! There's the chain rule. But wait, we can simplify. What do we do to simplify? Well, -3 times 4, -12. And voila, it's as simple as that. That is the dy over dx, our derivative. Nice and simple. Just remember to use this general form here, and it's going to save you a lot of time. You don't have to go through the full first principles process and say, oh, I hope I don't make an algebraic mistake or anything. And we've done the first one from our set of 3 down here as well, which is great. It means we're making good progress. So just to recap, and I will make a second part to this video where I'll do the other 2 functions, both within the same video. Just to recap, all I've really done is just taken the exponent, multiplied it by the coefficient, if there is one, put that as a big number, make it the coefficient, you know, the power rule, and then I just rewrote our gx term, whatever's in the bracket, as is, didn't even touch it. Now subtract 1 from the exponent, nice and easy, and then I found the derivative the last time, I just multiplied it. And again, if you ever have, you know, those kind of numbers there, it's nice to simplify. It makes things easier, and we have the derivative. So I could realistically plug in any value of x, and I could work out where on if I just clear this up, just so you can see a bit more, what the slope would be at a given point. So I could have, say, if x to the 2, I could just plug in 2 there, and I could work that nice and easy. So again, the chain rule saves a lot of time, and it's one of those rules that if you know, you can make sure your first principles is correct if you have to show first principles, because, well, you know how first principles is with all those terms everywhere. Anyway, see you in the next video. We'll go through both in the next video. It'll be nice. Hopefully you understand this. I've gone through nice and slow. The next video will be a little bit quicker because we have 2 problems to get through, but I'll see you then.